Yes, maybe just a double check if any of you guys, Lucky, Lib, can you confirm you can hear well and that you are online?
Yes, we can hear.
Hello, yes, we can hear you.
Okay, thank you. So in this part, we are going to see some little exercise to see how to create a geometry. So you need to have the software installed in your machine, and as well as have you the training material we share with you on Monday. And let's try to start with the exercise number 1. With this first exercise, I want to show you how to create a new geometry, and in particular how to create a new river and a ridge, then how to create and import the cross sections, how to set the roughness coefficient, how to modify the bank's position, and add the levies, which are the most important option that we have seen this morning. So first of all, let's open the HEC RAS. I will do the same time with you. If you have installed the software, you can just follow what I'm going to show you and try to do at the same time the same operation I will do. So I open the RAS software, and this is the main menu, as we saw this morning. Now we haven't started yet any project, so all these rows are empty. There is no file yet. So the first things we have to do is to start a new project. And you can start a new project just selecting from the file menu, new project. Then from this window, you can choose the folder in which you want to save your project. In this case, I choose a position in a folder I've already created inside the training, but you can choose the position you want in your machine, and you have to set a title to this project. So for example, let's save this one like exercise 1, so you will easily recognize which project is it, and confirm. When you create a new project, this message will appear every time. It's just telling you the information about the project. So it says you are creating a new project called exercise 1 .brj with the name of exercise 1, and it shows you the position you have chosen, and then they show you that this project will be set to the system international units, and it's a warning because you can choose if you want to use the system international units or the US customary system. In this case, yeah, confirm we want to use the system international units. So if it's not your case, you can change this option from the main menu, from the option menu. You can select unit system, and from here you can change the unit system of the project. So set the system international metric system, and check also the tab for the set as default for the new project. So in this way, all the new project you are going to create will be automatically created with this unit system reference. I forgot to tell you that in the training material that I give you, you can find for each exercise both the presentation in which are described all the passages that you need to do the exercise. There is all the eventually material, Excel file, DSS or shapefile, all the file needed during the exercise. And there is also a folder called solution in which you can find the project finished, like which is the final result of the exercise. So in case you have any doubts, maybe also in next days, you can check from this project in the solution folder and see what if the one you made today during the training session is the same, if there is something different, or if you just want to check some properties, some options from the final ones. Okay, so let's go on, and yeah, if you have any question at any moment, feel free to stop me and ask me. You can write in the chat, you can raise your hand, or you can just unmute and use your microphone. If you have any problem, we can see together. Maybe you can share your screen and we can try to solve together any problems, or you can also maybe send a screenshot of the error or something strange you notice in your doing your exercise. But yeah, please try to follow the exercise and doing the same things I'm doing, because it's really useful, I think, for you, this part of the training. So for now, we have create the project. So in the main menu, for now, you can see, in fact, there is the project file row that now is report the information about this new project we have just created. We have set the correct unit system, but in case you can always check which is the unit system of the current project. Just look in here at the bottom right of the menu. It's always written which unit system are you using for the selected project. Okay, now we want to create a new geometry. So in order to do that, you have to select the geometry button, which is this one, the third in the toolbar. When you click this one, the geometric data editor will open. Now it's completely empty because we do not have any geometric file yet. But we can start creating a new one from here. So the first step in creating a geometric data, like we saw this morning, is to create a river and reach. This can be done selecting the river and reach button, which is this one, the first on the horizontal toolbar. When you click this, your mouse pointer will turn into a pencil, and so you know that you are now in the edit mode and you can draw a river in the main window. So let's start digitalize a river path, and when you've done, you just have to double click to stop the digitalization. So for example, I draw a river path like this. When you double click, you stop digitalization, and the program asks you to set a river name, select an existing river name, or in case, enter a new river name, and also the reach name. So in this case, we do not have any river and reach, so we have to enter a new name and create a new one. let's call the river Nile. And for example, the reach, we can set Blue Nile. So we imagine we are creating a little portion of the Blue Nile River and confirm. Okay, now the river turns to the blue color and it's showing with this arrow, which is the direction of the flow. As you probably know, the river have to be drawn from upstream to downstream. So in fact, I digitalize it starting from this point to this point, and the flow direction is actually showing this. Okay, did you manage to create this new river? Message. Okay, thank you for the feedback. I hope that also all the other participants have managed to do this. And so let's move on. If you have any problem, just stop me, don't worry. So this is the river, the reach, we have set the name. Next step is to create the new cross-section within this reach. To create the new cross-section, you can open the cross-section data editor with this button. And then on the left, from here, you can select option, add new cross-section, and the window will ask you to enter a new river station, and then you have to enter all the data needed to characterize a cross-section. So the station elevation, the bank stations, the roughness coefficient, and so on. But sometimes it's easier if you have multiple cross-section to insert in a river, it's easier to import them. So for example, if you have the data of cross-section from a topographic survey, maybe you can think about, so there is a message. Okay, it was a confirm about the previous, okay. If you have cross-section data, for example, from a topographic survey, you have many cross-section, you can think to organize them in a file that can be imported in the RAS instead of insert manually each cross-section. So let's try to do this. For example, I've created a file. It's a CSV file, can be opened with the Excel, and here you can see. Now I will explain you better, but there are the schemization of some cross sections, and the format is like this. For each row, you have to specify to which river this row belongs to which reach it belongs to, and the river station of the cross section. And then with these two columns, you set the station elevation. So for example, starting from here, you see reach station number 0 until here. So all these points will belong to the first cross section downstream, which is named with the river station 0. So for example, all these points, let's try to plot them. Yeah, they are essentially the profile of one cross section. Then going down, you can see that the river station changes here. So these will be the points of the next cross section until here when the river station cell changes. So this one would be the profile of another one. So if you have multiple cross section, you can just organize the data like this, one cross section above the other. And then in this format, the cross section can be imported. Now I do not save this graph, but let's try to import this cross section in our new geometry. So to do this, you have to go and File, then select the import geometry data, and select the format of the data you are going to use. In this case, the file I give you is a CSV, so a comma separated value format. There are many other options. You can also import from a JS format, or from other HEC RAS project and other. In this case, let's select the comma separated value format. And then this window will ask you which file you want to import the cross section from. It will automatically put you in the folder where the project is saved. So in this case, I saved my project in the same folder I have also this file. If it's not your case, you just have to go and search for the right path in which you have saved the CSV file. Let's select it. And here it shows you you can select the format in which your data has been set. In this case, you can choose from EXYZ format or the station elevation format. As we have seen from the expal that I opened before, this is our case, the station elevation format, because we have the column disposed in this order. We have the first column with the river name, the second column with the reach name, the third with the river station, and then we have the station and elevation. So if you select this option, then you can confirm, and the import geometry data menu will open. Now there are different options you can select when you import the data. First of all, we show you that the current RAS project has the project units of System International. So select that also the import data has the same metric units and go on. So select next. In this menu, you can select which river and reach you want to import. In this case, we only have one, and so we can select this one. But in case you have multiple river or multiple reaches, you can decide to import only some of them, only one of them. You can select the list.
We are part of it.
Not that we are okay here.
Okay, so make sure that is selected the river and go on. In this menu, you will see all the cross-section. Here in this table are shown all the cross-section present in the reaches you decide to import. In this case, there are 4 cross-sections, and now they are all checked to be imported. You can see that they are all new, so that means they are not already present in your geometry, because in case you can also maybe import some data where there are some cross-section that you already have in your project, but maybe with the updated data, so you can import and substitute them with the new information, for example. In this case, we do not have any cross-section yet, so they will be all new and they will be all created from zero. So now you can finish and confirm the import process.
To make a good work, what should we need it now for them now to include in their management scale, bring out the project with a good result. Time, money.
Okay, sorry, actually I made a mistake because we don't have to check the import streamlines. So let's do this. Wait 1 minute, I just want to please some of you with the microphone turned on.
So in the group with the reporter and share.
Okay, sorry. Okay, so let's try to do this. If you're already done, like me, we made a mistake, sorry. So let's delete this geometry. No, we haven't saved yet, so let's new geometry data. So let's save this one, no. And let's call the geometry exercise 1. Or better, let's save it like Blue Nile. Okay, let's open the geometry data and let's do briefly again the river. So again, turn on the river reach button, draw a path, and then double click to confirm. Let's enter again the name of the river Nile and the reach Blue Nile. Okay, let's confirm. And now again, from the file, import geometry data, select the CSV format, select the file, confirm, and the format of the file we are using is the station elevation format, so select this option. Okay. Check the metric unit system for the new import to data, for the new data to import. Next. Okay, in this case, it was wrong because we already have the streamlines. We do not have to import it because it would be a streamline that you automatically created and it's not correct. All the other options are okay, so just keep like this and finish import data. Okay, the name of the reach in the file is Blue Nile with a space between Blue and Nile, while the reach I created is written without any space. So you have to select a reach, an existing reach, where to import. So select the correct name of the reaches, the reach you create in the geometry, and then you can go on. Okay. Okay, now you can see the cross-section if you open the cross-section data editor. These are the cross-section. With this arrow, you can move and see the different profile of the cross-section. Did you manage to import the cross-section? Does any one of you manage to import correctly the cross-section, or are there any problems?
Yes, I was able to import the figure.
Okay. Okay, so I will assume that also the other participants managed to do that. So from the geometry data editor, you can see the cross-section we have just imported, but there are still some information missing from this cross-section because we just import the, let's say, the cut lines, the location of the cross-section and their profile, but they all are missing the coefficient, running coefficient, the roughness coefficient, as well as the downstream reach lengths, and also the bank station are actually not realistic, because when you import the cross-section, some cross-section, the bank station are automatically set to the first and last point of the cross-section. But maybe that's not the right position, so you have to change after importing them. So first things, let's set the roughness coefficient. You can change manually for its cross-section, just writing here, like that's with 0.04 for the channel and 0.05 for the two overbanks. Okay, when you insert some data in this menu, you see that the new value are written in red, and also the plot, the axis and all the text turn to red. This means there is some new information you just entered that has not been confirmed yet. To confirm this new data, click on this Apply Data button. In this way, this new value has been set for the cross-section. But if you have many cross-section, probably the roughness coefficient probably will the same within a same reach. So there is another way, much faster, to insert the roughness coefficient, which is going from the tables menu. You can select Manning's K or K values. If you select this one, you will see the table with a summary of all the roughness coefficient for the river stations, and you can change this parameter in a much faster way. For example, you can select the whole column, and clicking Set Values, you can set to use 0.05 for the whole column, or you can select the entire table, set values, and fix a constant value. You can, in this case, it's not correct because we want to have a different value for the channel. That is just to show how it works. You can also use the replace option. In this case, you can look for a value and replace only the cells with this value with another one. you can do this replacement in the selected area or in the entire table. In this case, I want to change only the selected area, which is the column of the channel. The column of the channel is it's very easy to recognize because it's the one with the green background. From here, from this menu, you can also decide to see only some parts of the cross section. If you select all region like this, you will see the main channel in the middle, and the left column will be the leftover banks, while the right column, the column on the right, will be the right over banks. But you can maybe decide to show only the leftover bank, only the right over banks, only the main channel, or both the overbanks, but without the main channel. Let's go back to the all region. Let's check that the values we set are like this. So 0.04 for the main channel and 0.05 for all the other two overbanks. And click OK to confirm this changing. Okay, so we set the roughness coefficient. Then we have to set the reach length. We can do this in a quite similar way. From the tables, select reach length, and from this window, you can insert the distances for this cross section for the channel, the left overbank, and the right overbank. Because as we have seen this morning, these three distances can be different. In this case, the path of the river we have described, it's quite straight, so the distances between the main channel and the overbanks, it can be considered the same. So let's just write copy this value that I'm showing in the presentation. So the distances between the cross section at river station 7,590, the distance from the downstream cross section, so the distance between this and the one with the river station 5,120 is 24570 for for both left overbank channel and right overbank. You can select this cell and copy simply using Ctrl+C and then Ctrl+V. So what can we do is, for example, fill only the first column like this, copy the values from the PowerPoint presentation. Okay, I set the distances for the left overbank. Now I can copy all the 4 cells using the command from the keyboard, Ctrl+C, then selecting this 4 cell, I can click Ctrl+V and paste the same value also in this column and also in the other one. Okay, if you have set all the values correctly, you can click OK when finished to confirm this data. When you set the reach length, you should be able to see the imported cross-section in the geometry data editor. Sometimes it does not happen, like it happens to me now. I still am not able to see the cross-section, but it's quite simple to resolve this problem. Just then, first of all, are you seeing the cross-section, or are you having the same problem as me? It depends on some of the version of the program we are using. So probably if you downloaded the 6.6 version, it's like me, and you are not able to see the cross-section. Does any one of you are able to see the cross-section?
It's same as yours, Federica.
Okay, so probably is for all of you if you're using the version 6.6, but there is a quite fast trick to make the cross-section appears. You just have to click on the cross-section button, move with the arrows or from this drop-down menu, and select the cross-section with river station 7590. Okay, once you have selected this one, from the option menu, click on copy current cross-section. When you copy a cross-section, this message will ask you to set a new river station number. In this case, just increase of 1 meter the river station, so 7991, and click OK. So now you have created a new one, which is a copy of the last cross-section upstream we had. But yeah, you see that now the cross-section appears, but we don't want to have the one we just copied. So again, go to the geometry menu and select the one we just copied, and from the option menu, select delete. Okay, confirm this operation. Let's go back. Now the plot is not showing you correctly everything. If you go from the view menu, you can set the schematic plot extend and set to computed extend. It will automatically zoom in order to show you all the cross section. Otherwise, you can zoom with the mouse. You can also zoom using this command from the view menu, and you can just select the area where you want to zoom. If you want to move, once you have zoomed, you have to click the shift key from the keyboard. The mouse will turn into this hand, and so if you click with the mouse, you can drag and move to see another portion of the window. Okay, so are you now able to see the cross section in the window editor? Did you manage to do this?
Yes.
Okay. see if there are any questions. No. Okay, so now if you open the cross-section editor, you see that we have correctly the station elevation, we have set the roughness coefficient, we have the downstream reach length set for all of the cross-section. There is still one thing missing, that is the main channel bank station have been automatically set to the first and last point, but as you can see, probably it's not correct to assume all this part of the cross-section as the main channel. So we want to change the bank station position. There are 3 ways to modify the bank station. From the tables menu, the same menu we select to change the roughness coefficient and the reach length. There is also the bank station voice, and if you select this, you will have a table with the summary of the left and right bank station of each cross section. From here, you can select the single cells and change the values, but remember that the values have to be one of the cross-section station. So maybe it's not so easy to write the correct station without seeing the data of the cross-section. So you can't open at the same time the cross-section editor and check which is the station you want to set for the bank station. You can, for example, open maybe another file to set the to see the cross-section profile, or you can use one of the other 2 methods, which are from the cross-section data editor. So you can just modify from here, substituting the value. Here it's a little bit easier because you can check the station here, or you can click on the plot. For example, I want to set this point as a bank. If you click on a single point, you will be able to see the station and elevation. So in this case, for example, I can copy this value 185 here and set as a station. Or the third option, which maybe it's the most the best for me, but it depends on the situation, of course, is modify the bank station from the graphic cross-section editor. This editor can be opened from the Tools menu, Graphical Cross-Section Edit. If you select this voice, the Graphical Cross-Section Edit, you will see the cross-section like this. You can move this arrow and see the different cross-section, or you can select the cross-section you desire from this drop-down menu. But it's quite useful, this graphic cross-section editor, because you can select this button, the set the bank station, and you can just click on the profile to select and set the stations. If you select, for example, a point which is in the middle between 2 points, it will automatically set the nearest, so you don't have to be really precise and click on the specific button. But if you click like near this one, it will automatically recognize that you were meant to select this one. So let's do this operation for all the cross-section. You can try to identify the main channel as the middle part, something like this. We can do this for all the cross section. So let's move, for example, to the next one. In this case, I will say that the main channel is the part between these points and this point. So this is the left bank and the right bank. And notice that it will automatically recognize the left and the right. If I choose like 2 point like this, it somehow recognize that I was only trying to change the left overbank, and that's not the right overbank. If I move like this, and you automatically also see here up in the upper part the coefficient that will be set between these 2 points. So let's fix the point like this and move to another cross section. In this case, I will set the main channel like this. So move through all the cross section and set the bank's position in a more realistic position. Okay, I've done it for all of my cross section. Okay, did you have any troubles doing this modification of the bank station? Remember, you have to go to the Tools menu and select this graphical cross-section edit. From here, select the button for the bank stations and then simply click on the station you want to select as left banks or right banks. When you have done, you can like save the geometry because we have changed a lot of things. It's better to save. Okay, any problem? Someone can give me some feedback or go on?
Yes, you can move forward.
Okay, thank you. Okay, for this small exercise, there is one things we can already change in this geometry, which is to set some levies if needed. So again, you can go from the cross-section editor and from the option menu, select the levy option. Here, for example, I would like to set a levy here, but I should know the correct station and the elevation, and it can be a little bit difficult, let's say. There is a much easier and faster way, which is using the graphical cross-section editor. We have used also to set the bank station. So you can go to the tool menu and select again the graphical cross-section edit. And from here, from the option menu, you can select add levies, and you can simply click on the position you want to set for the levy. For example, I want to put one here, maybe one here. Let's see if the other cross section would need a levy. For example, if I put a levee here, I will be sure that if the water surface, which is like this elevation, this part of the most right part of the cross section will not be included in the flooded area. Same things also for this one. For example, I can set a levee here. And for this cross section, I think it's okay. I see there is a message in the chat. It is essential for both riverbank points to be at the same elevation. It's not essential, but usually it's like this, so that the main channel is compressed between 2 points that have more or less the same elevation, just because usually there are some banks which have similar elevation. So in this way, this part will be considered main channel. So let's say the water will flow in the main channel until the water surface level is at this level. And you know that if the water surface goes above, and it will start to compute the flowing with the bank's roughness coefficient. So usually, yes, it's a common rule to set the banks, right, left and right banks at more or less the same elevation. Let me know if I was clear enough. Okay, perfect. Okay, so this one was a very short example of how to create a geometry, how to import some cross section, and how to edit the most important parameters, which are the banks and the levee, and how to insert the reach distance. Let's save this one, and if you don't have any other question, let's move to exercise number 2. Let me use this one. Okay, in this new exercise, we are working as well on the creation of a geometry, but in this case, we want to create a geometry based on topographic information like a DTM, and this can be done using the RAS mapper. We haven't seen yet the RAS mapper, but it's a very useful tool that allows the user to use also georeference file and manage many other data. With this exercise, we are going to import a DTM, so in a raster format as a terrain for the model. Then we see how to import the river reach in a shape format, how to import cross-section location, and how to extract the cross-section profile from the terrain. So how to use topographic information as the DTM to extract the cross-section profile. And then we see also how to import the bank's location. So first of all, let's start a new project. If you are already here in the main menu, you can create a new one from the file menu, new project. Do you want to save a current? Yes, save the previous one, and then I can create a new one. I suggest you to save the file in the same directory you can find the training materials or the exercise 2. So in this way, you will have already there in this folder also the shapefile folder and the terrain folder, which contain the data we are going to use. So I select this folder, the exercise 2, and set the title. In this case, let's set exercise 2 and click OK to confirm both the title and the position of the project. As before, is asking you if you are sure to create this new project with the file name exercise 2. It shows you the position of the file and it highlights the unit system. In this case, it's SU units, and it should be like this also for all of you if you correctly check the option set as default I showed you before. So if the unit system are not the system international, go to the option unit system and select the system international and also check this set as default for the new project. If you already done it for the previous one, now you should have obtained already the correct unit system. Okay, before starting creating geometry and data and so on, let's see that the HEC RAS mapper is an interface you can open from the main menu and provide the user a geospatial visualization of the RAS geometry, but also of the results and other geospatial data, which is quite useful to create a better river hydraulics model. In particular, the RAS mapper give the user the opportunity to edit some layers, some RAS data layers, but also some generic shapefile that can be imported, and also to visualize the results in the maps. It is especially used for the bidimensional models, but it can be really useful also in creating one-dimensional models. You can open the RAS mapper clicking on this button. The RAS mapper window will open and you see this is the RAS mapper interface. So there is a main menu system on top of the window. When there are some menu and some button you can select. There is a data layer list on the left. Here you can see all the layer you have in the current project. You can add new layers. You can also select, edit, and modify the existing ones. Then on the bottom left, there is a status window. Here you can see the messages and any status warning that the program will give you. And then there is the mapping window, which is the main window when where you are able to see all the layers. You can select, edit, move, and do everything you want to the layer you have. So we have created this new project. Let's open the RAS mapper. And the first things we want to do is to upload a terrain. So you have to select the terrain layer from the data list menu, turn on by checking the tab next to the terrain text. Then if you right click on this layer, you can select the option create a new RAS terrain. If you select this one, okay, this message will appear because essentially with the RAS mapper, we are going to work with elements and information which are georeferenced. So you have to set a projection for this project. You can firstly set a projection file before doing anything other in the RAS mapper, or another option, which is the one we are going to do, is to use directly the projection file of the terrain we are going to upload as the projection for the whole project. So in this case, if you click yes, you can go to the window. No, sorry, you have to select no. It's the same, but if you select create a new RAS terrain and you say no, you go directly to the new terrain layer editor, and from here you can select the DTM you want to upload. To upload a new terrain, you have to click this plus button you find on the left side of the window, and then you have to search for the path of where is located your DTM. In this case, the DTM I give you is located inside the folder terrain. So you have to go to the folder exercise 2, then inside terrain, you will find this TIFF file selected. Okay, now he is asking you if you want to use the spatial reference system of this file to be used for the RAS model. In this case, yes, you have to click yes. And then click create to confirm your choice. Okay, in this window you will see a lot of process, but the process of creating this terrain can take a little bit depending on the size of the DTM you are uploading. In this case, is quite small, so it shouldn't take too much to create the terrain. When you see the operation is complete, you can just close, and now you can see this DTM uploaded in your RAS mapper window. If you select this layer on the top, on the bottom right, you will also see this scale bar, which show you the elevation of the terrain. One really useful option is if you double click on the layer terrain, and if you turn on this option, update legend with view, this is really useful because in this way, when you zoom in and move, this color bar will automatically update according to the portion of DTM you are seeing, and this allow you to have a better definition of the DTM, because as you see, the minimum and maximum value changes when I zoom in or zoom out. And if I move, it automatically rescale according to the portion I'm looking at. Okay, have you uploaded this DTM? Did you have any problem? Okay, thank you for the feedback. So I move on. So we have uploaded this terrain. So we have now topographical information of this portion of River Nile. Now we want to create a geometry. We can create the geometry also from here, from the RAS Mapper interface, just clicking on the geometry layer in the data list on the left, turn on this layer, and if you right click, you can select create new geometry. You have to set a name. I call it exercise 2. Confirm. And then from this menu, you can select the terrain you want to associate to this geometry, because in a single project, you can also upload more than one terrain. And in this case, if you have more than one, you have to set for each geometry which is the terrain you want to use. You can have multiple geometry, and as well you can have multiple terrain. So from this manage layer association, you can set which geometry is using which terrain. In this case, we have only one, so you can just confirm and close this menu. Okay, now you see that below the geometry layer, there is this exercise 2, which is our new geometry. Now it's quite empty, but if you select the geometry and you click on the edit button, which is this one, the pencil, a lot of new layer will appear, and these are all layers that you can start edit, and you can add feature inside each of these layers. In this case, our geometry is still empty, so the first feature we have to create is the river. So select the river layer. From here, automatically is selected. If you see, there is this toolbar with some button. The first one is the button to add a new feature. See, so if you select this one, you can start drawing the river wherever you want. Just clicking, you can move with the mouse, and you can digitize a river. When you double click, it will ask you to set a name of the river and of the ridge. This is just a test. I'm not going to save this modification. It's just to see. With this second button, it's the edit feature button. If you select this one, then you can select some existing feature. And if you double click on it, you will be able to modify it. Maybe changing the vertex of this polyline. You can both select a point, click and drag to move it, or you can insert new points between two existing. Like this, you can click and then drag and select and choose the right position. There is also the command to undo and redo the changes you have done. And when you have done all these modifications, you can click on this red button to stop the editing mode. This way of editing the layer is somehow similar to the QGIS. When you select a layer, you turn on the edit mode, you do the modification and save. In this case, stop editing and do not save. This was just to show you how it works, because I want to show you that you can also import the river delineation from a shapefile. In fact, in the folder of the exercise 2, in the shape folder, you will see there are 3 different shape files. One is called banks, one is called cross section, and there is also one called river. They are all shape file that now we are going to use to create the geometry. So again, let's select the layer, the geometry, exercise 2, turn on the edit mode, so you will be able to see all these editable layer. Select the layer rivers, and if you right click, you can select import features. If you do this, from this window, you will be able to select the file you want to import. You have to click on this button on the left, sorry, on the right part of the window. From here, you have to move and look for the file. You have to select the river shape file, which is located inside the shape folder. So it's this one. Okay, you will see an overview of, there is a preview of the feature contained in the file. It is displayed here in a window. As you can see, here in the left table, sorry, there is one question. Can you repeat on geometry creation? Yes. Okay, so let's go back. Just, okay, I cancel this operation, so I will do it again with you. To create a new geometry, you have to, let's use this. You have to select the geometry layer, and with right click, you can select create new geometry. You have to enter a name of the geometry. In this case, I name the geometry exercise 2. Let's create a new one, then I just delete it. So from this menu, here an example, if you have more than one geometry, you will see the different geometry and the terrain associated to each of them. In this case, we only have one, so you have no choice. Essentially, it automatically associates this one to all the geometries. Sorry. So you can close this menu and you will see a new layer here. In this case, now I have 2 different geometries. One is called exercise 2 and one is called new geometry. I just need one. So for example, I can delete this one. Just right click, delete geometry, and yes. Well, this exercise 2 is the geometry that now I'm going to work on. Is it clear? Did you manage to create this new geometry? For now, it's empty, so you just see this layer because there are no feature inside this new geometry because we haven't do anything yet. But now we are going to create all the feature and all the elements needed for the geometry. Was this your question, or maybe in drawing the river? Okay, I hope it was clearer this time. So let's try to move on and create the proper geometry. So if you select the geometry, in this case exercise 2, turn on the edit mode and select the river layers. Right click from this one and select import features. You have to select the file you want to import, just clicking on this button on the right and search for the file, the shapefile called river, which is located inside the SHP folder. That's the river shapefile. I confirm this one. This is the preview of the feature contained in the file. If you click import, you will see this is the river path that I've just imported in my geometry. So let's stop editing and save this modification. Okay, so now we have this geometry with the layer river, which contain this river. The shapefile has already have its own name of the river and the reach in this case, so it automatically say, you can see the river name is main Nile, while the reach name is Atbara Delta, because this is a portion of the Nile extracted between the portion that goes from the Atbara tributary to the delta. It's just an example. Okay, so now we have the river, and as before, we want to create also the cross section. You have to select the geometry layer, turn on the edit mode, and select the cross section layer. Again, as before, you could use this button to add new feature and just draw them on the river. You can edit with this button. So for example, draw a cross section, setting the first point, which is on the left side. In this case, the river, the flow river goes from the south to the east part. So when you draw the cross section, you should draw from left to right. So like this, select the first point on the left, the second on the right. If you double click, you confirm the position of the cross section. This is one method. You can draw the cross section wherever you want along the river, and you said that this number is the river station, which is automatically computed by the RAS, and you see that the number is increasing going upstream. So for example, if I draw a cross section really close to the end of this river, the river station is pretty small. But if you are working with a very long river, maybe you do not draw a cross section randomly along the river, but maybe you can create some cross-section with a constant distance between the previous one, the next one. So in this case, for example, I have prepared a shapefile with the cross-section equally distanced. We want to import, so stop edit without saving this cross-section, but go back on the edit mode, select the cross-section layer, and again with the right click you can select the import feature option and search for the file called cross-section, which is located as well in the shapefile folder. Again, you will see this preview showing you all the cross-section position. You can also select only some of them. We see, or you can import. In this case, we want to import all of them. So select all the cross-section in this table. Click import. Okay, and these are the cross-section we are importing. Just stop the edit mode. In this case, let's save. Okay, and these are the cross-section with a river station, which is automatically computed according to the river reach we have imported. Okay, did you manage to import the cross-section? Are you able to see them in the main window of the RAS mapper? Okay, it said no. What kind of problem you have? How? Okay, did you, because you can find the file or something, some error occurs? You want, you can like use your microphone and try to explain, or do you want me to repeat some of the passages? Okay, here's a screenshot. Let's see. Okay, it seems that the layer cross-section is not, it has not been created. So you have to try to do it again. Select the, let's use this. You have to select the layer of the geometry, so the exercise 2, because now you can see the cross-section layer yet, but if you turn on the edit mode by clicking on this button, the yellow pencil, it should appear also the cross-section layer. You have to click on it, and then once you have selected the cross-section layer, right click and select the import feature option. This window will open and you have to select the file you want to import. You have to click this button on the top right of the window. From here, you have to search for the file, which is named cross-section.shp, and it is located inside the shapefile folder on the exercise 2 folder from the training material we gave you. So you have to select this one, cross-section shapefile, confirm, and here you will see a preview of all the cross-section. If you just confirm like this, the program will automatically import all of the cross-section included in the file. Now I already add them, so I click cancel, but if you click import, it should work. Tell me if there are still some problems. Okay, from this screenshot, it seems okay. You see the preview of all the cross-section. So from here, if you click import, it should work properly. But no, okay, seems okay. Let me check in the first one. Okay, the river was okay.
Federica, we are missing your voice.
Okay, sorry. Can you hear me now?
Yes, now. But I guess that the last 2-3 minutes you
So
were.
long. Sorry, I don't know
Yeah.
why the microphone turned off, but I don't know why. Okay.
I thought it was me, so I got out and in the meeting, but then it was the same. Then I also saw
Okay.
comment from one of the colleagues here. So yeah, please, if you can maybe go back for
Okay, sorry, I didn't realize.
two actions, and then there is also Leib who has raised his hand.
Okay, sorry. So I don't know exactly when you lost my voice, but okay. So we imported the cross-section, but we just imported the location of the cross-section. The most important thing we want to do is to obtain the profile of the cross-section by extracting it from the DTM. So to do this, you have to select the cross-section, the cross-section layer, turn on the edit mode, and right-click on the layer, update cross-section, and select from here the voice elevation profiles from terrain. When you do this, you will have a message here in the note box that see that all the cross-section have been set to cut from the terrain. They will cut as needed or whenever you save the geometry. So it means that when you save the geometry and you click yes to confirm the change in modification, the profiles of the cross-section will be extracted from the DTM. There is still one raise hand, no audio again. Or can you hear me now?
Yes, I think
okay,
we can
it
hear
was
you.
an old message. Okay. Okay, so to check if the profile have been correctly extracted from the DTM, you can go to the, let's close the RAS mapper for now. You can go to the geometric data editor. The first time you open the geometry data, you do not have still the geometry. You have to open and select the geometry we created in the RAS map. Then you will be able to see the geometry. So with the river and the cross section, and you can just select on one of cross section and select edit, or otherwise it's the same, just clicking on the cross section button. And here you can move through the section and see that that's the profile extracted from the DTM for all the cross section we have in our geometry. Okay, has happened also when we import the cross section from the geometric data editor. The bank station has been automatically set to the first and the last point of each cross section. Is happened for all the 17 cross section we have in the geometry. We can, like before, change here from this table. We can change from the graphical cross-section editor. We can change from the tables. But in this case, we can try also to change from the RAS mapper, which is another way, pretty useful. In the shape folder, you find a shapefile called banks, which contains the lines connecting all the cross section. Because essentially, if you go to the river layer and click the plus button, you can see there is the bank lines layer. If you check the tab and turn on this layer, you see there are these two polylines that connect all the cross-section, intersecting each of the cross-section at its extremity. So essentially, these two polylines set the position of the banks for each cross-section. So you can like draw new polylines, knowing that the bank's position corresponds to the intersect point between this polyline and the cross-section line. So I have already prepared a shapefile which contains two polylines that moves along the river and represents in a more realistic way the position of the banks. So we want to substitute this polyline with the shapefile I prepared. So select the layer bank lines, turn on the edit mode, selecting this button. Then make sure to select this button, the edit feature. With this one, you can select the feature available in this layer. In this case, select both of the polylines and right-click, selected feature, delete. You can delete these two and import the new ones by right-click on the bank lines and select import feature. So again, from this menu, you have to select the file you want to import, and you have to select the file called banks. This is the preview of the two lines, and click import to confirm your choice. As you can see, this polyline follow the banks visible from the DTM, and in this way, the bank's position for each cross-section will be set exactly where this polyline intersect the cross-section. So each cross-section will have a new position of the banks. To update the position of the banks, you have to select the cross-section layer, right-click, go into the update cross-section and select the option bank station. In this way, all the position of the cross-section will be updated as shown here in the message box. Computing bank station done. When done, you can just stop editing and save. You can check the bank position going to the geometric data menu and open the cross-section data editor. You see that now all the bank's position has changed, and this has been done for all the cross sections in the geometry. Okay, let me see if I saw everything. Yeah. So this is a different way of create a geometry. If you have some topographic information like a DTM available, you can work on this, use it as to extract the profile, but also to draw a realistic path of the river, select the position of the cross section, and also draw the banks in a more accurate way, because creating a good geometry is the first step to obtain an accurate model for the hydraulic simulation than you want to do. Did you manage to import also the banks line and update the location?
Federica, I see Lib has raised his hand. I don't know if it was for the voice missing or if another question maybe.
I don't know, Lib, do you have any questions?
No, I don't have a question. Just the time when your microphone is switched off.
I did not hear very well.
I say I raise my hand during the time when your microphone is switched off.
Okay,
I want
okay.
you to, yeah, I want to tell you.
Okay, okay.
So basically, okay. So basically, then just to make a little bit of a summary here, Federica showed you today how to create a geometry for RAS one-dimensional model. It's a pretty complicated program. I would say more complicated than HMS. But still, once you can manage the geometry, you have done most of the work, I would say. So tomorrow, you'll see how to create all the other components of the model, so mainly the boundary condition, and then how to launch a simulation and see the results. But definitely the geometry thing, the geometry part is the most time consuming and most important. So you have seen there are, for one-dimensional model, there are at least two ways to create the geometry. In case when you have cross sections, you would go for the classical geometry data editor, importing or adding the data of the cross sections. When you have a more like a DTM, you might want to use the RAS mapper, which is a sort of GIS. It is a GIS basically, but it is a GIS that is embedded into the RAS model. The same thing that you found in HMS, the Bayesian delineation component is a sort of GIS embedded in HMS. Anyway, the important thing is that at the end, either in a way or in another, you create a geometry for the model that contains the river, the cross sections, the banks, the distances between cross sections, and then you set parameters like the roughness coefficients that are needed for the geometry. I'm just trying to summarize here, and I think that yeah, for today we can stop here. If you have any question, we can probably dedicate few minutes more in case. So open question for everybody, if any. I don't see any question. Federica was so clear and so good that you have understood everything. For sure, you have the training material that is pretty well done and clear. But if you can maybe go through these two exercises that Federica showed you today, and maybe tomorrow morning you might come with some doubts and questions, we are more than welcome to see all the challenges or questions that you have gone through. So other than that, I think we can adjourn to tomorrow morning then, 11 a.m. your time. Thanks, Federica, for chairing this working session. Yeah, I guess I hope that everybody, I saw Zeriun has shared at the moment the list, the form to be filled. Hopefully each of you has filled it, or anyway, hopefully it will be available also tomorrow in case somebody didn't. So yeah, let's meet tomorrow morning, same time. I don't know, Federica, shall we share a new link for tomorrow? Probably it's better so that we don't make any confusion.
Yes, in the afternoon I will share you a new link for tomorrow, and I also will share you the folder in which you can find the recording of these 2 sessions of today.
Okay, very good. So thanks a lot, everybody. See you tomorrow then. Bye-bye.
Thank you. See you tomorrow.